Welcome. You've got mail.
Today we're working on a LeetCode problem for removing the nth node from the end of a list. The definition is, given the head of a linked list, remove the nth node from the end and return its head. A list node is defined up here as having a value and a next, which could either be null or the next node in the list. So in this example here, we want to remove the third node from the end of the list. So we're given the head of the list, which is 1, and it's highlighted in green. And we want to remove the third node from the end, which is 4, and that's highlighted in red. So the input will look like this, and the output that we want to send out is just returning the head back with the third from the end removed. One possible solution for this is to traverse the list one time to get the length of the list. So starting from the head, we keep going until the node.next is null, recording the length of that. So we get the length of 6. And then we restart back at the head of the list, going in length minus n spots into the list. So this would be 6 minus 3 spots in. 1, 2, 3, count there. And making that node dot next equal. So we basically skip the next node, removing that node from the list. This would require multiple passes, and it can be a bit slow. So what we're going to use is 2 pointers, and that'll mean we only need to go with the list at most 1 time. So just as an example of that, we're going to use a fast and a slow pointer. So we're going to make the slow pointer equal head, and the fast pointer, you could either make it also equal head or make it head.next. That only matters for your for loop. So for the fast pointer, let's make the fast pointer green, slow pointer red. So the fast pointer, we're going to increment that until we reach the value of n. So if you're starting at head, start your for loop at 0, and if you're starting at head.next, you start the for loop at 1. So you increment that till it reaches n, the value of n basically. So if we're starting here, 1, 2, 3. So if there is no fast right now, which means we've gone outside of the bounds of the linked list, we would just return head.next because that's the closest one that we have to the end. If there is, we continue to increment the fast and slow pointer until there is no more next for fast. So when we've reached the end and the fast no longer has a next to it, because we know that's null, we know that the slow pointer is the node before the node that needs to be removed. So using the same logic, we just do this to skip this and extend the pointer over here, and then we would just return the head again to have your completed list. The coding solution for this, we would just create 2 variables for slow and for fast. Then we loop through the fast until it gets to n. This would make sure the space between the 2 pointers is n. So if there isn't fast, if we moved to a null state for the fast.next, we can just return head.next at this point. If there is a fast, And there's a fast.next. Keep incrementing both the pointers one forward. Until the fast pointer reaches the very end. And then we can set slow.next to be slow.next.next. So if we run this, should pass most of the cases, or should pass all the cases. So that's the solution. Hope it helped.
Goodbye.